Hi everyone, welcome to Homework Help. Let's go ahead and get started. Special guest Delilah today. What is the quotient when the sum of 1, 2, and 3 is divided by the product of 1, 2, and 3? So for 1, 2, and 3 first, we have to add, since we are finding the sum. And then for the second set of 1, 2, and 3, since we're finding the product, that means we're going to be multiplying. So you want to find the sum of 1, 2, 3 first, then the product of 1 times 2 times 3, and then divide both of those to find your quotient. For number 2, this is written wrong. You want to correct it two different ways. One way would be with the dollar sign, and they would still include the decimal because our amount is less than 100, so it's less than $1. And the other one was with the cent sign, but it's not going to include any decimals because we're talking about the raw number of cents. So there's no need to include a decimal when we're already talking about cents, unless you're talking about parts of cents, which is not a thing as far as actual currency is concerned. But if you've ever gone to the gas station and you see that something is like $2.39 with an extra 9 at the end, basically the gallon is $2.40. They just add that 0.009 cents to make a little bit of extra profit. It's very sneaky. Anyway, number 3, replace each circle with the proper comparison symbol, then write the comparison as a complete sentence using words. So here we would find the proper comparison symbol. Again, you can choose greater than, less than, or equal to, but only after you've actually evaluated. So 1/2 stays 1/2, and then we have 1/2 times 1/2, and you find that product, and then compare them. Remember with fractions, if the numerator is the same, the smaller the denominator, the greater the value. And the way you would write this in words is 1/2 is, and then greater than, less than, or equal to, the product of 1/2 and 1/2, which whatever that may be. Now for this, it's something similar. -2 is greater than, less than, or equal to -4. As a reminder, the smaller a negative number is in terms of absolute value, the greater value it actually has. Number 4, 26,000. We want to write this in expanded notation. So first things first, you have to write it in numerical form. And then you have to write it in expanded form. So that's going to be 20,000 plus 6,000. And having done that, to write it in expanded notation, you then just set up your parentheses. Remember that the place value is going to be, so this is in the 10,000, so it's going to be a 1, and then you're going to write 10,000. And then the other factor is just going to be the first number that comes at the beginning of that, which in this instance is 2, and you do something similar for 6,000. For number 5, a dime is what fraction of a dollar? So we know that a dime is 10 cents out of a dollar, which is 100 cents. And from there, you just simplify it to find the fractional part. Now, to find the percentage is actually interesting because, again, it's 10 out of 100. Now, the fact that it's already out of 100 tells you that the only thing left to do is look at the numerator and write that by itself as a percentage. Whenever you have a fraction that's out of 100, the numerator is already the percentage. For 6, the flag to the right is a nautical flag that stands for letter J. What fraction of the flag is shaded? So we have 3 parts. So the portion that's shaded will be out of 3, and the portion that's not shaded will also be out of 3, since it comprises the same amount of fractional parts. Number 7. Is an imaginary line from the Earth to the Moon a line, a ray, or a segment? So we were to draw a straight line connecting the Moon and the Earth. A line would actually keep going on forever, so it's not going to be a line. It'd be a ray if it had one starting point and extended forever the other way. But since it starts and ends, that makes it a segment between the Earth and the Moon. We're skipping number 8. For number 9, the first thing you're going to do is find the factors of 18 and 24. So we can use our divisibility rules to find some factors. Once you have all the factors, the next thing to do is write down for C all the factors they have in common. So again, I can already tell you that 1 and 2 are some of those factors. And then find the rest of the common factors. Once you've found all the common factors, then select the one that is the greatest, and that will be your greatest common factor. For number 10, if n is equal to 2/5, we want to find the sum of n plus n, which is 2/5 plus 2/5. And since they already have the same denominator, you just have to add them. Keep the denominator the same and add the numerators. And then for b, we have 2/5 minus 2/5. And again, it's the similar setup where we subtract the numerators and keep the denominator the same. For 11, we have b plus 85,000 equals 200,000. So to find the value of b, we're going to use our inverse operations. We're going to subtract 85,000 from both sides and then find the difference of 200,000 and 85,000. For 12, we have 900 divided by c equals 60. Since c is a divisor, in order to find the quotient here, or the value of c, we just flip the c and the 60, so it'd be 900 divided by 60. 13 is a monetary problem, so we have d plus $5.60 equals $20. Since they're being added, we're going to subtract 560 from both sides. We're going to make sure we line up our decimals. Yes, that is a 5. And then we just regroup and find the difference. For 14, we have e multiplied by 12 equals $30. To find the value of e, we're going to use our inverse operation. So instead of multiplying, we're going to divide both sides by the factor with e, which is 12. And make sure you simplify as far down as you can. Now for 15, we're subtracting. So the inverse operation here would be addition. And again, you want to be careful and make sure that everything is lined up in terms of place values, in terms of decimals, and that you just add it all up, and then that's it. Now for number 16, we're being asked to find the sum of all these numbers and then find the value of n. So what I would do here again is I would group numbers together based on, I would make 10s. So 5 and 5 make 10. 6 and 4 also make 10. 7 and 3 also make 10. And then 7, 1 and 2 make 3, plus 7 is another 10. So you have n, and you're adding all these 10s, and that whole sum is 40. So the only thing left to do is find the sum of all these 10s and then subtract it from both sides to find the value of n. For 17, we're going to subtract the whole numbers, subtract the fraction parts of it, and just make sure that you simplify if you can. Remember that when you're subtracting fractions, the denominator is going to stay the same, and the only thing that's going to be different is the numerator. For 18, again, we're going to add the whole numbers. We're going to add the fractions, keep the denominator the same, add the numerators. For 19, we're going to multiply straight across, 3 times 1, 4 times 4. So the denominator is not going to stay the same. It will be multiplied, and it'll be something different. For number 20, we're just going to use long division, 1,802 divided by 17. Set it up using long division, and then you follow your very simple formula of divide, multiply, 17 times 1, subtract, find the difference, and then bring down and continue in that fashion. For 21, we're just going to subtract. Remember to regroup and to make sure your decimals are lined up the way they need to be. For number 22, we have 607 times 78. And again, you can use the standard algorithm for this, or you can use the box method that we were shown, where you just multiply everything inside the box and then you find the sum of all 4 numbers. For 23, another multiplication of fraction problems. Again, we just multiply straight across. 4 times 2 is 8. 8 times 1 is 8. And then you also multiply the denominators, 5 times 3 and then times 3. For 24, we just add the numerators, 1 plus 2 plus 4. The denominator, as always, will stay exactly the same because we're not multiplying. For 25, 50 times 36 times 20, we're being asked what steps will make this easier to solve. First one's the commutative property. Since we changed the order, that's going to make it easier for us to solve. Second step would be the associative property. Now the 50 and the 20 would go together inside the parentheses. And then from there, you do 50 times 20, and then take that product multiplied by 36. For 26, what property we're being shown, we take a number, multiply by its reciprocal. The answer is 1. Any time that you multiply a number and its reciprocal, the inverse property is coming into play because the product will be 1. For 27, we're being asked to describe the relationship between A, B, and X, Y. They are two lines. However, they're not intersecting, but they're also not parallel because they're not pointing in the same direction. Since they're on different planes, they're actually skew lines because they have no type of relationship. For 28, we're being asked to describe which angles are acute and which segments perpendicular to CB. So acute angles are going to be those that are less than 90 degrees, which BAC is one of them, and this angle is also acute. Remember that the middle letter should be where the angle, where the two rays or the angle is located, and then the other two letters can be formed around it. Which line is perpendicular to CB? That is a line that helps to form the right angle, and that segment will be the perpendicular segment. For 29, we're being asked to describe the following sequence and then find the next term. It appears that the denominator is doubling every time while the numerator is staying the same. And then finally for 30, how many 2/5 are in 1? I know we kind of went over this in class using the box method. I'm going to show you the box, but before I do that, I'm going to tell you that the reciprocal of 2/5 is going to be the answer here. These are all fifths. This is one whole box made up of fifths. And you want to know how many 2/5 are in here. So we have 1 2/5, because you see that it's two segments. And we have 2 2/5. So we have two entire ones. So we have 1, 2, and then we have half of a 2/5. So you'll notice that if you were to combine these, you get 2.5 or 5/2, which is the same as the reciprocal. So this has been your homework help for today. Your extra credit is going back to that problem about the Earth and the Moon. The extra credit will be to write down the distance from the Earth to the Moon. How far apart are they on average? That would be your extra credit for today. And that will be it. So moon distance. So make sure you write down your homework. Thank you for tuning in. Hope you have a great day, and we'll see you tomorrow.